Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is my homework solution for lesson number 13, extra credit. Paul Mahorter does several training classes for electronic engineering, and the one that this homework lesson's for is Raspberry Pi Pico W. Check Paul out, he does a great job on videos. Let's go over here and look at what the homework assignment was for this one here. Paul asked us to use 3 potentiometers with an RGB LED. He wanted each potentiometer to control one of the colors of the RGB. It's pretty much a straightforward project, but it's going to require some math. So let's look at what I did for the math here. Let me scroll up here. You can be able to see a little bit of math. Sorry, my nose itched. We're going to use the formula. Well, what I end up doing is, we know from what Paul had taught us before, is that we take 2 points to make a line, and then we use point, slope, intersect to be able to convert that over. But then from what we learned from the last 2 lessons ago, is Paul would like for us to do a y exponential, or an exponential growth on the return of the y. And so what that means is that when we turn a potentiometer or user input or some kind of form of input that we're using an LED, we would like for to have the illuminance to continue to grow the whole length of the turn of the potentiometer. So what I end up doing here for the math, we know what 2 points. We've got 0, 0, and we have 65, 535, and 16. So then we use delta y over delta x, or y2 minus y1 over x2 minus x1 equals m. So we have 16 minus 0 over 65, 535 minus 0. Simplify, equals 16 over 65, 535. Now we need to get to the point slope intercept. That formula is y minus y1 equals m times x minus x1. Which we're going to go ahead and simplify it down to what I have here, which is an exponential value that we're going to be using for our exponential growth formula. So it's exponential value minus 0 equals 16 over 65, 535 times pot val minus 0. Simplify it. Exponential value equals 16 over 65, 535 times pot val. Let's scroll up here a little bit so you can see what we did for the exponential value formula. What I did for the exponential value formula is take the color brightness equals 2 times, or 2 to the power exponential value. The 2 asterisks is what you use for Python to show that you're wanting to times that. Now, since we had that formula, let's go ahead and look at the code here that we've done. I'm going to have to switch some screens around here real quick to need to push this one up. Well, turning around here real quick, moving some stuff around here. Hang on with me. Let's start with the way how I wired up this circuit. We see here that we have the Pico W, and we're going to come off with the ground pin of number 38 coming down to the ground bus, and then it feeds off to the ground of the RGB and the 3 grounds for the potentiometers. The next one that would come off is the 3.3 power out and coming to the ground, or coming to the bus at the top, and that's going to go to the power leg of each of the potentiometers. The next one down is GPIO 28, which is going to be for the red potentiometer. The next one is going to be GPIO 27, which is coming right down here for the green potentiometer. And then the last one is GPIO 26, which is for the blue potentiometer. Then we come over here to the other side, and we have for the GPIO 13, it'd be the red, and it comes over to the RGB. The green is GPIO pin 14, and the blue is GPIO pin 15, and they're all on the same column as a 3.3 resistor. And that all ties into the respective colors of the RGB. Now let's look at the schematics. I just like to do schematics, even though it's just a repeat of what we just did for the lineup. But for those who are working on electronic engineering, this is what you'll be seeing a lot of, or making yourself. So might as well start learning it now, or getting used to seeing it all the time. This is our RGB. This is our This is our Raspberry Pi Pico W representation of our breakout development board. It shows our GPIO pins, representative on the sides, and then we have our wiring coming out. Let's go ahead and look at the RGB coming out. And we, just like we said before, GPIO pin 15 goes to the blue, GPIO pin 14 goes to the green, and GPIO pin 13 goes to the red. Tying into the ground, and we're using ground coming off here onto the pin 33. And the ground also kind of ties back over here to our potentiometers, and I have them as blue, green, and red. The reason why I did it in this order is because I didn't want to cross over my wiring. And then we have for our reading our resistance GPIO pin 26, GPIO pin 27, and GPIO pin 28. We have 3.3 volts coming out and tying into the proper legs on the potentiometer. Now, since we got that out of the way, let's look at the coding. Alright, this is the code that I use for just to let you know, whoever, in case if you're wanting to use a Visual Studio Code with your Raspberry Pi Pico W, I did a training course on that on my website, or not on my website yet, but it's actually over on my YouTube videos. I did a little video to show you how you can bring in and be able to use your Pico W with Visual Studio Code. Alright, back to here. Okay, we import the library of machine and the classes of pin, PWM, and ADC. Bringing in the library time, and we're bringing in sleep with the sleep milliseconds. I just started doing this, kind of like it. It just looks to me nicer when I declare the value for the variable, and I have 100 instead of 0.1. Just me. You can do sleep. I just prefer to do that way. Okay, then I cleared my global variables. We have red, green, and blue pot valves and respective GPIO pins of 28, 27, 26. Red, green, blue of the LED RGB with the respective GPIO pins of 13, 14, and 15. Did our time delay of 100, which is 100 milliseconds. And when we create our objects, we have red, green, blue potentiometer objects with declaring ADC, analog to digital conversion, and then we do the red, green, and blue with the pot pin that we just declared prior. And then we have a red, green, and blue objects for our pulse width modulator running to our RGB. We had that declared here with a frequency of 5,000 and a duty cycle of 0, so we're wanting to be able to shut those off right now. Now we'll go down here to the functions. I ran my math into the function formulas. I just want to kind of make it cleaner, and that's just the way how I did it. So I declared my functions as a red LED brightness, bring in the argument of pot val. Then I ran through here pot val, read pot val, pot value, read pot value, holding that in there. Express val will take that conversion over to being able to use for exponential growth curve, and then our brightness will read that exponential growth curve, and then we're going to return that as an int. Paul does a great job on several different of his courses talking about that when you read from an analog to digital conversion, it will be a float in Python, and so therefore you need to convert it over to an int, because that's what duty unassigned 16 requires. Then I ran another function, and I wanted to be able to display the readouts, as you'll see here in a little bit, from 0 to 255 to be able to fine-tune. If any of you are web developers, you know that your coloring most of the time is either in my mind just went blank. 0 to 255 or 256, counting, but 0 to 255, or it's hexadecimal. But we're not going to do hexadecimal right now. Just to make it easier, we're going to go from 0 to 255, reading on our printout, and be able to help fine tune. Now let's start our loop. While true, continuing to go, which I declared try first also. While true, then we're going to say red duty for unassigned 16 with bringing our function in there. And then we're going to do a print statement, like I said, to be able to just show where it's located at. Same thing with green, ran our function inside the value for returning the value. And blue, we did our sleep milliseconds of 100 milliseconds, and then we have an accept interrupt, keyboard interruption would shut everything off. Don't need to waste power if not using it. That's how I kind of feel. Alright, let's run it. One thing I do like about Visual Code Studio is you can run it here too live. So I'm going to pull up, let me pull up the camera view over here for you. Go down here and wow, I didn't realize we're going to have this little problem here. Bear with me as I switch this around. I'm going to have to tell this to use, to use that, no, to use the other monitor. I thought I had this all set up, sorry guys. And turn that back on. So there we go. And we're gonna shut me off, and so you can be able to see the board the full time. Alright, now since you can see the board, but you really can't see very much of everything else of the code. Whoops, wrong one. Let's adjust this so you can see. There you go, just a little bit, not too much. Alright, let's get this running. And as you can see from the printout, everything's shut off, and you can see from the RGB that there's no color being displayed. I'm leaning over here, and I'm going to put, well, gonna have to use two hands here real quick. I'm going to turn on the red, and I'm going to turn it up, and you can see it slowly increasing. Now we have full red. Now I'm going to turn it down so we can turn on the green. I'm going to adjust this too while we're doing it here, and then turn on the green. You can see the green is starting to lighten up. It gets brighter and brighter. And then we're going to do the red, or sorry, blue. And turning on the blue, and the blue gets brighter and brighter. And back down. To be able to show that we can mix colors, orange requires a different display out on the green. So we're going to go to the green, and we're going to be looking for our printout to go to 165. Right about there. Well, a little bit over, but that's okay. And then it's going to require red to be full. So then we're going to increase our red to full. And we got orange being displayed. So it's showing that we can mix. I'm going to turn full on green. And that should give us yellow. And if we turn the green off and turn on blue, we should get magenta. And let's go ahead and make white, which would be all of them, be fully on. And now all of them are fully on, and we are displaying a little form of white. To me, I see the blue kind of overpowering, but I don't have the best color vision for green and blues. I'm slightly colorblind in those. Information about me. All right. We got that extra credit homework done. If you have any comments or questions, leave them at the bottom. Talk to you again. Until next time, be safe out there. I think